Now, starting off with question 3, right? So they say in the diagram below, we are shown wavelength of frequencies of different types of electromagnetic radiation. Consider the diagram and answer the questions that follows. Now, on this diagram, here we are given different types of lights as well as their frequency here at the bottom, and this is their respective wavelengths. So now, 3.1, they want us to explain how is an electromagnetic wave created. Now, basically, when you create your electromagnetic wave, right? So basically your electromagnetic wave originates from accelerating your electric charge, right? And magnetic fields that are perpendicular to each other. So basically, when you accelerate your electric charge as well as your magnetic field, and these two, when they are perpendicular to one another, and as a result of them being perpendicular, they are accelerated, an electromagnetic wave would be created. Now, this is where the names come from, electromagnetic, because here you're accelerating electric charge as well as your magnetic field. So hence here, this wave is called your electromagnetic wave. And remember, these two are perpendicular to one another, or rather they're accelerated perpendicular to one another. Now, 3.2, now name 3 other types of electromagnetic waves that have a frequency lower than your ultraviolet light. Now, let me highlight my ultraviolet light. So the question wants me to name 3 other types of electromagnetic waves that have a lower frequency, right? And I must arrange them in an order of increasing frequency. Now, if I do so, right? So basically here, to choose those 3 which have a lower frequency and in an order whereby they are increasing, so I have these 3 options, 1, 2, 3, or 4 options rather. Which one am I going to choose? I'm going to choose the ones which are closer to my ultraviolet, meaning that, remember, they must be in an order whereby they are increasing, right? So our frequency, as you could see, it's increasing in that direction. So as I've said, I'm going to choose the 3 which is closer to our ultraviolet. So I'm going to choose this as my first, this would be my second, this would be my third. All these 3 have a lower frequency compared to your ultraviolet. And if I put them in an increasing, right, frequency, or in terms of increasing frequency, your microwave has a lower frequency compared to these. So basically it will be microwave. So writing them down, my first, be the second, and the last, it will be the visible, right? And in this particular order, what happens is that as I name them, right, my frequency increases in that particular order. They're telling us that a photon has a wavelength of 700 nanometers. So we need to calculate the energy of the photon. Now, when you're calculating the energy of a photon, what formula do you go about using? So I want you to try and pause the video and try to attempt this question on your own. So we're going to make use of our formula whereby the energy of the photon, it is equals to your h, which is a constant, multiplied to your frequency, right? Now, in this instance, what is it that we have? So we are given what? The wavelength. Remember, if I were to expand this formula, this would be h. And what is the formula for your frequency? Right? Remember, the formula for your frequency, it's c, which is the speed of light, divided by your lambda, which is your wavelength. Now, h, as I've said, it's a constant and it's there at the back of your question paper. Now, this h is equals to 6,63 multiplied by 10 to the power minus 34 multiplied by, as I've said, c, it's the speed of light, and the speed of light is 3 multiplied by 10 to the power 8. Also, this is there at the back of your question paper. All divided by your wavelength. And now, most importantly, your wavelength must be in terms of meters. So here, it's 700 nanometers. We need to convert it to meters. How would you go about doing that? So everything when it's nano, so nano, you need to multiply by 10 to the power negative 9. So to convert the 700 into meters, we will take 700 and we would multiply it by 10 to the power negative 9. Now, this also applies when you are given or on electrostatics. Let's say this is given as 5 nanocoulombs. Now, remember, we're dealing with our charge must be in terms of coulombs, not nanocoulombs. So to convert this into 5 coulombs, you would say 5, because there is a nano here. You want to multiply this by 10 to the power negative 9. And this would be equal to your coulombs, or rather, this would be the coulombs that we need to make use of, right? Because remember, this must be in terms of coulombs, not nanocoulombs. 700 multiplied by 10 to the power negative 9, punching it into your calculator, right? So you would get 0, so there are, I think there are 1, 2, 3, 4, 5, 6 zeros, 3, 4, 5, 6, and 7 at the last. So you can also substitute it here, or you could substitute it at 700 multiplied by 10 to the power negative 9. Now it's important to not round off up until you get to your final answer, right? So remember, the only time we round off is when we are at the final answer. So now you want to punch this whole thing into your calculator, right? And now when you do so, your energy of your photon should be equal to 2,84 times 10 to the power negative 19 joules, right? Remember, the unit for your energy is joules. Now, the preceding question wants us to calculate the frequency of the photon. Now, remember the formula for your frequency. It is c, which is the speed of light, divided by lambda, and we already done that here. So remember, your speed of light, it's 3 multiplied by 10 to the power negative 8, to the power 8 rather, sorry. And then your wavelength, it's 700 multiplied by 10 to the power negative 9, because this was in terms of nanometers. Now, punching this into your calculator, you would get the frequency of the photon. Now, remember, we already did this before, and this was the part, but then we did this while we were calculating the energy of the photon. Now, punching this into your calculator, your frequency should be equal to 4,29 times 10 to the power 14. Alternatively, you could use the energy of your photon formula. Now remember, you calculated your E as 2,84 times 10 to the power negative 19. And this is equals to your H. Remember, your H is a constant, which is 6. So I'm going to put this in bracket, 6,63 multiplied by 10 to the power negative 34 multiplied to F. Now to solve for F, because it's multiplying, I'm going to do the opposite. I'm going to get rid of the 6,63 by dividing it times 10 to the power negative 34, so that these could cancel out. And remember, what you do on the left, you must also do on the right. 6,63 times 10 to the power negative 34. Now, punching this into your calculator, you should get your frequency. And your frequency should still be the same value. Rounding it off, it should be 4,29 times 10 to the power 14. And remember, the unit for your frequency is hertz. Right? So you could use one of these two formulas. Now, in the next video, we're going to be continuing with question 4. Make sure you stay tuned.